The broadcast is now starting. All attendees are in listen-only mode.
Good morning, ladies and gentlemen. Welcome to SolidCAM UK's webinar. This is the second part on the HSS style of operations. Today we'll be dealing with something which it's a wee bit different. We're going to be looking at a trimming using the simultaneous 5-axis operations. Now the simultaneous 5-axis operations work in the same manner and use the same strategies as HSS. It's just HSS with an extra 2 axes. So the files that we're going to be looking at today I've created earlier just to show particular aspects of how we can work. And as usual, things have got off to a good start, so I had created an extra operation of SolidWorks 2015. The first one we're going to look at here is just a spherical surface with 4 lobes. Now, to those of you who do vacuum forming or GRP moldings where they have to be trimmed, this type of operation around the edges is going to be familiar. So how do we approach this? Well, the 5-axis machine that we've chosen here is a Gouge machine, and we'll have a look at the characteristics of this machine before we start. So I'm going to open the machine simulation and I'll pull it onto their working screen at the moment. Now this is typical of many types of head machine where you have the axes. Let me just lift this up and turn it about. We've got an axis which can turn round about the Z-axis that way, and we've got a tilting axis which can go either way. Now there are limits to what a machine like this can do. As you can see there, this one can go between A minus 125 and A plus 125. The problem arises in this type of machine with the rotation around about the C. Now here, this particular machine setup model is allowed to rotate freely between 10,000 and minus 10,000 degrees. Now on a table machine where the C-axis is the rotary table, then that's acceptable. But on a machine like this, the parameters would normally be set so that it would be between, say, minus 270 to plus 270 or slightly more. So as far as going round about an object continuously, this is not possible. However, SolidCAM copes with that and can show up any errors and give us a chance to fix them. So how did we do this? Now I have actually created this earlier this morning just to test that everything was working in my setup, rather than come in and have it fall apart all over me. We did a little bit of preparation today. So what have we got here? Dimensionally, this is about 610 by 610, and the envelope it's within is about 191, 200 mil deep. You'll see I've got the datum sitting above the part. In this case I just captured the datum from the view. Because it's a spherical surface, there's nothing on it to click on to be able to give us the view. So in actual fact, if I close that down, I'll show you that aspect of it. And this is the second model we're going to be looking at. Now I haven't tried this one at all. This is the sort of thing that may be made for a cowling, for an engine, for an old tractor, or something like that. Again, we've got this same feature where you have edges. Let me switch on the edges and we can see how the edges break up there. Now this is quite important actually, because in one of the things that we're going to do, it may be that you get into a position where you don't want in here when this is coming down here, you don't want the head to be perpendicular to the face. So in an instance like that, we can actually create a sketch and we can put some lines on here and we'll say, right, at this point we want the head to be along that vector. As we come over the top here, we may want it to delay a bit as it comes round. We may want it to go down here like this, and then it will morph between that and that as we go round the corner. We can steepen it by the time that we're here. These are little tricks that allow us to control the way that the head moves on this type of machine. Now, this one has got flat surfaces, so sorting this one out is going to be pretty easy. So what I'm going to do is just hope we can get it in the machine, is we're going to start a new CAM file here, new milling, and we'll save that first. I'm going to do it as an internal part, -1. OK. And we're going to define our coordinate system. I'm not too bothered about where it is. So we'll select a face and we'll say center of the top center of the model box, and we can select that face there and it'll put our datum up there. There's many ways that this can be reached. If this was sitting on a form sucked down for holding purposes, then it may be that we know exactly where that is in relation to somewhere in the machine, so it can be set up without too much trouble. Now this is simultaneous 5-axis work, so we don't need to set up any other datums unless we choose to. The stock in this case, I'm actually just going to choose the part. 3D model, rather than have a lot of material to take off of here. For demonstration purposes, we'll just pick the solid. So the target and the stock will be exactly the same. And again, our target has already been picked automatically in this case. Okay, nothing else I need to worry about there. So, what are we going to do first? Let's take this round hole here. We've got two distinct surfaces in there. We want to be perpendicular to this face, and we want to take this 5mm depth. Oh, sorry, it's 10mm. So we'll take it and try and take it in 2 or 3 cuts. The tool that we're going to use, and we'll define that just now, is a 6mm burr. I'm just going to go with the standard sizes there. They're long enough. I will, however, put a holder on. And we'll use an HSK 32x80. So 80, 80, 24, 30. Outside the holder 60. Seems a bit much. Outside the holder we'll make that 35. Okay, and as you see, our tool up here is modified to suit. Feeds and speeds, depending on what you're going to do, about 1500 would probably about what we're needing here, and maybe plunge at 1000. And on a machine like this, you could be anywhere up to 25,000 RPM, so we'll stick it in there about 18,000. So that's our tool defined with the holder in place. Now in our operations, we're going to use the simultaneous 5-axis machining, which is distinctly different from HSS in the fact that the HSS works with 3 axes. Here, as you'll see, the same modules are available. So, how are we going to do this? Well, first of all, we need to think about how the tool's going to approach this surface. So, we will pick our surfaces first. Now, always the drive surface in this case. And here, it's always a good idea to check to see the direction. The reason for this is that's the surface normal, and that's the positive side is the side of the surface that this module will attempt to attach the tool to. So if it's going the other way, then it will be on the wrong side of the surface and it would overcut by twice the diameter of the tool. In this case, it's shown. It's always a good idea just to check this while you're creating it. So we'll call this round hole cut out. Now, there are a number of different strategies that we can use here. Parallel cuts would just probably not give us the best option because it's going to be cutting along a direction, like so that way, or in constant Z, or at an angle. So for this type of work, parallel cuts is more for cleaning the surface than it is for trimming. So what we want is possibly parallel to curve, parallel to surface. You can use morph between two boundary curves here because we have an upper and lower surface, and I believe you can use projection as well. The ones that I've always used is parallel to surface. So while it sorts itself out, we'll go to the geometry page and you'll see that we've now got an edge surface. Now which edge do you pick? In actual fact, the surfaces that we want to pick are these two, because they form the surfaces that go right round about the hole. So we'll click edge surface, round cut drivers, and I'll choose that and that. And again, we'll just have a quick check. Oh, sorry, my apologies, I'm rushing here, and select all. We'll choose that and that, and say here this is not so important, but from the point of view of being familiar with the model, I can have a look and see which way the surfaces are pointing. Okay, levels. Levels in this case are not the same as they are in 3-axis or 4-axis machining. The level here is the distance that it will retract when it comes out of the cut, how much the entry safety distance is when it's going into a cut, how much the space will be before it changes from rapid to feed. And in this case we've got 10 mil deep here, so I'm going to make that 12 mil so that at maximum it's going to be above it. And the exit safety distance we'll leave it 2 because when it comes into that it's going to be retracting anyway. We'll make it rapid retract as well. There's several different ways that we can work our clearance plane. In this case you can see that possibly on a table machine where your C-axis is rotating, the cylinder may be the appropriate one. We also have sphere, which may be appropriate on a table machine, but in actual fact I tend to just stick with plane, and we can choose which of the planes that we wish to use it, or we can in fact describe our own. So the plane height here is 25 millimeters. I'm going to leave it at that. Toolpath parameters. This is what our step over will be. Now in this case we've got 10 mil and we want to take it in, say, 4 cuts. So we'll go 2.5 for the step over. Your surface quality, you can cut down the tolerance right down or up. You can select your own tolerance by just selecting the button and closing it off there. We'll leave it at 0.01 at present moment. Sorting. The distance, the way that we cut this, standard, zigzag, spiral. Now on a head machine, zigzag is probably the better because it will keep it within a 360 degree loop. So hopefully if it starts at the right place it will go and come back without hitting the head limits. So we'll leave this at zigzag. If this was being done on 3-axis, then I would probably use spiral, and it would just do a continuous spiral cut to get to the bottom. Here we'll use zigzag. Standard order, just follow. We can choose, as you can see here, from center away or outside to center, and it just changes the way that it works. In this case, we're just going to leave it at standard. Flip step over, we'll see in a minute how it changes the way that it works. But we haven't defined how the axis is going to handle this at the present moment. So let's take a look at that next. So I'm purposely going to leave this just exactly as it is, and I'm going to simulate it. It would be a good idea if I actually selected a tool. So save and calculate this. Now straight away, because of the experience I have with this, I can see that the direction that the tools come in there is perpendicular to the surface. And if we simulate this and we go into the machine simulation, we may have to go in a couple of times just to modify this so we can see it. Let's let it draw. And it's put the part on. So what have we got here? What have we done wrong? On a machine like this, we have to use the setup. At the moment, this is sitting with the 0 flush on the table. So this has to be set. Some of you may be aware of this, some of the people that use 5-axis, some may not. So how do we get round about that? Well, that's what the machine setup is for. And in this case, I'm going to add on 500 millimeters in the Z only and say OK. We'll calculate this and we'll go and simulate, and again choose machine simulation. And this time you'll see that we now have the part sitting above the table. You can see that the spindle has gone red. This is because there's a collision between the body and the head. One of the good things about machine simulation is it has this feature. Now if I move up and you see the collision stops, collision on, collision off, etc. So at that you can see I have not compensated for the fact that the tool, we need to work on the edge of the tool. So in our operation there are two options that we can use here. Tilted relative to the cut condition. Now we may wish to put a lag or a lead on this where the tool leans forward or back. In this case I'm just going to tilt it to the side, so I'll put -90 in here. And again we've got two choices. We've got plus and -90. As you can see, it now has 4 cuts round about the inside. If I go back and I put 90 in, and simulate this, you'll see that our tool is in the wrong side. Now you may say, why didn't it automatically sort it out? Because there are so many connotations here and you may wish to do so many different things with it, it's up to yourself to check that that is in the right orientation. Now that's a perfectly legal toolpath if it's in this orientation. It would, however, crash through whichever way you did it because it's trying to get to this side. So that illustrates how you can easily go wrong, but it's just as easily fixed. So now if I put -90 in there, save and calculate, and we'll simulate that again, and let's see where we are, and you'll see the tool is on the right side this time, just the way that we want it. Okay, we'll speed that up a little bit. So let's have a look at that in the machine simulation and see how it's going to do it. Right, okay. Right, let's run this. We'll slow it down a wee tad. And you see that there are little adjustments of the head there, but it will cut that without any problem. So that's the first part of this done. Right, which one are we going to do next? Let's look at a piece of the external. Now if we look at if you remember, I created some bits and pieces on the edge of the surface here. Now let's look at going from, say, this bottom left hand corner here to here. Now there's not much of a swing in the head there, so we should be able to do that without too much trouble. So save and copy. And in here in the geometry, I'm going to choose my new drive surfaces, which are going to be these ones. That and that. Okay, let's go back and edit that and check to see which way the surfaces are going. I've created this from a surface with a thickening on it, so everything is working tickety-boo. However, if you get an IGES file that's come in from another program, you can have surfaces, and it's only a surface, you can have them going in many different directions. Okay, so how are we going to drive this time? Again, we'll go for edge surface, and we'll create a new selection here. And there we go. Again, we'll have a quick check. Okay. Tool will be our same tool. And select this. And as we already had the tool axis control set, all I'm going to do here is just calculate this, and let's have a look at what we've got. Now you can see our entry point down here at the front. Everything looks okay. However, you really need to check to see that it actually is okay. So we'll do a quick run here and see how our tool is operating. And as you see, that's quite nice. We'll let her come round the loop. Tool's tilting back nicely. And on we go. And on up and over, it'll be the same on the other side. Looks like a nice tool path. So let's simulate it in the machine simulation and see what happens. Now we'll come on from this side, and we'll slow it down and let it go relatively slow. Now here's our nice tool path. Lovely. Oh sugar, we've just crashed into the machine. Oh sugar, it's done it again. It's alright on this bit. Rotating round about to sort itself up for this side. Down here fine. And on this side, so far so good. But we've caught it there again. And obviously we can't machine it like that. So how are we going to cope with this? Now there are a couple of things we can do. The first one that we're going to try is I'm going to put a conical limit on this between 0 and 45 degrees. So we'll save and calculate that again, and we'll go straight into the machine simulation here this time. Okay, let's look and see what happens now. Tool comes down, that's fine. Nope, we're still hitting it. It's coming over, gets to 45, that's okay. Turned round about. Tool's just going digging in a wee touch there on the rotation. Coming down the other side, it's got itself to 45, that's fine. And whenever it straightens up, it hits it again. How are we going to do this? So we'll stop that and we'll come back out. What I actually did there is we have a choice that we can put limits on. Now whenever you put a limit on, SolidCAM will change the way that it holds the tool to be within those limits. So 45 was fine there for coming up and down vertical surfaces, but on the flat surfaces next to a vertical surface it wasn't very good. So let's try this and let's say we're going to put it between 30 and 60 and see what happens here. We'll simulate that. So let's see how our tool's going to set itself up this time. Something not right there, something's not engaged. Limits 30, 60, save and calculate. And that's going to do exactly the same again, so it's not coped with it very well there. We could follow this on for some time, however there is another way to do this. And that is using these markers that I previously put on. So we have a better understanding now of what's required. So even from within, I'll switch these off, even from within SolidCAM, if I go on here and now create my lines, I can see at this point by here I want to be off like that, and we'll actually keep that orientation until we get to here, and we'll allow it to stay perpendicular I'm just picking up the ends of the surface lines here. We can quite happily come round there, but as we're coming down now we want to be in a position where the head's under our control. Oops, picked the wrong bit there. We'll keeps picking the wrong one. That's me, not the software. Pick that there. Now it'll not matter whether it's long or short. Come on, play the game. Why is it picking that up like that? Anyway, down at the bottom here we need to be still at an angle there, so we can pick up that and it will go around the corner, and by the time we finish we'll be vertical again. So I'm going to save those lines and edit the operation again. Tool axis control, and now we're going to choose tilted through lines. And as you can see by the example here, that the lines that we pick are the direction of the tool center at that point. So we're going to start off here with our first line and make sure it's pointing up the way. So that's fine. Say OK to him. Comes round the corner. Now we were all right here, so we can rotate this. Now our next one, we'll pick this line, and that's fine, the direction's right. And we'll follow in here with the ones that we created to begin with. We'll follow that. Again, number 5. And I'm just going to go for here for number 6. We'll miss out that one in between. Number 7. Number 8. Number 9. 10. 11. As you can see, all of these have the direction out the way. Now at this point we would have been crashing here, so we'd choose that line there, and we'll choose that one there as the next one if it lets us. That's it again, and we'll finish up on our last line, which we have to change the direction. Right, now we'll take the limits off now, because we should be under the control of the lines. So, step forward, you'll see this time we're coming from the other side, calculated it a slightly different way. The tool is coming round, following what we suggested. We'll allow that continue till we see where it's going. We may need to tilt that line a bit more. It's come round and it's working its way up over the surface as we wish. It's doing its rotation now to bring it down the other side. It's coming up and over, and again we're needing to do a wee bit more work in there, change the way that the lines go, but in general we're now getting the idea that it's under our control. So that's it's done its first pass. So the areas that we need to look at are the way that it comes down around this area and the area here. So that's just a case of modifying these contours. So here, let's edit this one. Let's bring you out more horizontal, and you're not too bad. Say OK to that. 2, 3, 4, 5. That one I think there needs to be adjusted. It's just too steep. Now let's synchronize this. The lines are all in the same place. We'll see if this part of it works okay. Simulate, machine simulation. This side we know we haven't adjusted, so it'll still crash. Maybe need a bit more control in this area, so we can add in or move these down. Let's go in and just check our geometry is still connected to, there we are. As you can see, our lines are in place. This one's not been used at all, that may be the problem there. So let's look at moving that one up. That one should be used. Anyway. A little bit of work required then in this side yet, but that other side is almost there. The little red bit is just showing us that there's a couple of bits that we need to just do some work on. It's the holder that is gouging, not the tool. So if we were using a different holder, it may be, let's go and do that. We'll change our holder type. Let's use this and see what we do now. Oh, it hasn't updated the holder. Let's go back into the operation and reselect the tool. Idiot. We haven't properly selected it, so we'll cancel that, come back out, and we'll do it in here. So in the holder, we'll select that. It's now available in our local holders, and we should now have our tool changed over. Yes, there we are. It's updated. Save and calculate, and we'll simulate. Machine simulation. So now you can see we have the different holder in, and if we run the program, you'll see that now that we're using the different tool, we have a better result. Still a little bit in there. It may be that there's it's okay. It's just as it's come round this corner, it's left it slightly. Okay, you can touch that up without any problems. Right, so that's the basics of trimming. Let's go back to our other file and have a look at how we can use the Simultaneous 5-axis for machining surfaces. This would be exactly the same as, or very similar to, using it for, and we'll machine this surface here with the tool perpendicular to it and following the edge contour. So I'm going to leave that one as it is. It works, not bothering. And we'll add A new milling operation, new simultaneous 5-axis milling. Now in this case I'm going to cheat a little bit. I'm going to say we're going to use the drive surface, which is the top surface, and the edge surface, which is the edge surface. We're the other way round about on the other one. And my tool axis control here I'm going to change to not to be tilted, to stay normal to the surface. After all, this is a square tool that we're using. Or it would be if we'd picked one. So we'll pick exactly the same tool again. Save and calculate, and let's see what's generated. It's creating the toolpath. There's a 1mm step over by default in here, and this is quite a big surface, so it'll take a second or two to create it. Just a few seconds more while it's processing this. Now at the moment there's no surface offset, so this would be a finishing cut. Simulate this, we'll do it first here, and then we'll put it into the machine simulation. So you can see at the moment this is starting from the centre and working its way out. I'll let it go, and as you can see it's following the form and working out to the outside. You can choose which way we go just by changing the surface step over. Change the step over. So that would allow you to machine this surface. So say this is quite big. The ball's got a radius about 300 mils, so it is a fair size. And that's that. Now let's have a look at the machine simulation and see what it's going to throw at us. Okay, here we come. And as you can see, I've already put the machine set up to bring the ball above the surface. Now let's let this run. And you'll see as it works its way out, it's keeping the tool perpendicular to the table, the surface. Move this roundabout so we can get a different view of it. Put the toolpath on so you can see it, although it may be a bit confusing. But as you can see, that's working away nicely. It's following the contour. And that will continue on until the outside. So that's one of the ways that you can use the HSS style with the simultaneous 5-axis. You can machine the surfaces just as you would before, but you have the added advantage of being able to cope with the 5-axis operation. I'm going to leave it at that today, and we hope to hear from you again in the future. Okay, my name's Ronnie Smart, and thank you for joining us.